Page 18 of complex numbers and polynomials. Number 3, a real polynomial of degree 5 has leading coefficient -1 and zeros of -2, 3 plus or minus I, and square root of k plus or minus I, plus or minus 1. The y-intercept is 18. Find k and the coefficient of x to the fourth. So we know that a polynomial has all the terms multiplied times some degree of x, like x to the fifth, x to the fourth, x to the third, x squared, x, and then the final coefficient, which is not a coefficient but a constant, has a special role. It's the y-intercept, because remember the y-intercept has coordinates 0, comma something. If I put 0 in for x, do you see how all of these terms will become 0? And the only thing left over is the last term. And the last term is the constant and is also the y-intercept. And they tell us the y-intercept is 18, so we know that the last term is plus 18. We also know that the leading coefficient is -1, and we know the zeros 1, 2, 3, 4, 5 zeros. They give us all the zeros, and we just don't know what k is, right? So we can figure out k, though, because we know that if we multiply all of these zeros together, we're going to get basically 18. The actual rule is this. If we take 18 and we divide it by -1 and multiply it by -1 to the fifth power, then we will get all the roots multiplied together. So let's do that. So a0 is 18, an is -1, and -1 to the fifth is also -1. So these actually cancel out, and they're equal to all the roots multiplied together, and the roots are -2, 3 plus I, 3 minus I, and square root of k plus 1, and square root of k minus 1. Okay, so we have 18 equals, so -2 times, this would be 9. These two multiplied together is 9. These two multiplied together is -1 times -1. It's -1 times -1, which is +1. And then the inner and the outer terms cancel each other out. And then we're going to do the same thing with square root of k plus 1 times square root of k minus 1. That'll be equal to k plus, k minus 1. So that would be -2 times 10, which is -20, k minus 1. So that would be equal to, let's see, now we have 18 equals -20, k minus 1. We can divide both sides by -20. We get -9/10 equals k minus 1. So k is equal to 1/10. Let's look at part B now. Part B is talking about the coefficient of x to the fourth. And remember that this is a degree 5 polynomial, so x to the fourth is the second term. So the second term, we know that the coefficient of the second term, which is a to the n minus 1, or a fourth, negative a to the fourth divided by a to the 0, or a to the n, sorry, which is a to the fifth, is equal to all the roots added together. Okay, so in this case, a to the fourth we don't know. A to the fifth we know is -1. And we know that those are all the roots added together. And the roots are -2 plus 3 plus I plus 3 minus I plus k, square root of k plus 1 plus square root of k minus 1. And then we'll cancel stuff out. So plus I cancels out. Minus or plus 1 minus 1 cancels out. And then we're left with, and of course these two cancel out too. We're left with negative 2 plus 3, which is 4, plus 2 square root of k. Okay, 4 plus 2 square root of k. So 4 plus 2 square root of k is 4 plus 2 square root of 1/10. Some mathematicians don't like having the radical in the denominator, so let's try to get rid of that. So we have 4 plus 2 over, and square root of 1 is just 1, square root of 10 is square root of 10. Let's get rid of square root of 1. And let's put both 4 and 2 over the same denominator. So we'll have 4 square root of 10 divided by square root of 10 plus 2 over square root of 10. And then we'll say that's equal to 2 plus 4 square root of 10 divided by square root of 10. And then we'll multiply both the top and the bottom by square root of 10. And we'll get 10 on the bottom and 2 square root of 10 plus 40 on top. As a last simplification, you could divide everything by 2. So then you would get square root of 10 plus 20 plus, or divided by 5. Okay, so that was the first problem on the page. Now we're at number 5. A real quadratic polynomial has leading coefficient 1 and 0 of the form a plus or minus I and 3 plus or minus a, where a is from the set of real numbers. Its constant term is 25. What are the possible values that a may take? Okay, so the constant term means the a subscript 0, which we know is related to the product of all the roots. And let's see, the roots themselves, leading coefficient of 1. So we know that a subscript 4 is 1. And we know that a subscript 0 equals 25. Okay. And we know the zeros are this form here. So let's go back and say, okay, we know that if you multiply negative 1 to the 4th, a subscript 0 divided by a subscript 4, that is going to equal to all the roots multiplied together. So basically that's equal to 25 divided by 1. So that's equal to a plus I times a minus I times 3 plus a times 3 minus a. So let's expand this. So we have a squared minus I squared, which is plus minus negative 1, which is plus 1. And then we have 9 minus a squared when we expand these two. And then can we do FOIL on this? So 9a squared minus a to the 4th plus 9 minus a squared. So we have negative a to the 4th plus 8a squared plus 9 is equal to 25. So not it, minus a to the 4th plus 8a squared, and then we subtract 25 from both sides, so we get negative 16 here and 0 here. If we want to, we could like invert the negative signs of everything. So a to the 4th minus 8a squared minus 6 plus 16. So we could factor this. It would factor into a squared minus 4 squared. Okay, and that is equal to 0. So a squared minus 4 is equal to 0. So a squared is equal to 4. So A could equal plus or minus 2. Is that all they wanted to know? What are the possibilities of A? Yeah, I guess that's it. So on 6F, we're going to look at different kinds of cubic functions with different kinds of roots. So the first cubic function of type 1 has 3 real distinct zeros. So that means its 3 roots are different real numbers. So I'm going to draw 2 examples here. So there's the x-axis. So one of the possibilities is this, which is a cubic that crosses the x-axis 3 times, 3 distinct times, and each one of those crossing points is a distinct zero or root, and it could go that way or it could go that way, right? So that's number 1. That's type 1. Type 2 is 2 real zeros with 1 repeated. So that would look, let me draw x-axes here. That would be something like, it could be like this. So here it touches there and it touches there. The repeated root looks like that, where it touches and it goes back. And the single root is the one like that, which is, it crosses, okay? So there's that, and there's, there's maybe like this kind too. Okay, something like that. There's some mirror images of those too. Type 3, 1 real zero repeated 3 times. So that would be something like that. Okay, so the inflection point is like right on the x-axis. Type 4, 1 real and 2 complex conjugate zeros. So that would be something like it crosses once, and the other time it doesn't even cross. It just like goes up and comes near it and then turns around. So it could be like that. Could be like that. Okay, so those are the 4 types of cubics. Number 2, find the equation of the cubic with the graph. And so they give us a few different examples here. And so basically we know that the cubic equation is going to have the form y equals a, and then 3 linear factor terms, kind of like this, and each one's going to have the x-intercepts. So this was going to be x minus -1, x minus 2, and x minus 3, and we just don't know what a is yet. Okay, so we're going to simplify this a little bit. We're going to put x plus 1, x minus 2, x minus 3. Okay, and we know that one of the points is going to be 0, 12. So if we put 0 in for x, so it would be a times 1 times -2 times -3. If we multiply all that together, we'll get the y value of 0, 12. Okay, which would be 12. And then we'll say a times 1 times -2 times -3 is 6a equals 12. Then a is equal to 12 divided by 6, which is a equals 2. Okay? C. So in C, I have 2 x-intercepts, 3 and -4. So I'm going to write that this cubic is going to be x minus 3. And you can see that 3 is a single root and -4 is a double root. So it would be x minus -4 squared. So it would be a times x minus 3 times x plus 4 squared. And we know that one of the points that can be used to figure out what a is 0, -12. So we could say -12 equals a times -3 times 4 squared. So that's going to be -12 equals -3 times 4 squared, which is -3 times 16, which is -48. A, so a is equal to -12 divided by -48, which is 1/4. Okay. And last of all, we have this one. It's got 2 roots, -4 and 3. 3 is a double root, so it looks kind of like a times x plus 4 times x minus 3 squared. And we know that this is equal to 0, 9 at some point, so we'll substitute 0 in for x and 9 in for y. So we know that's 9 equals a times 4 times -3 squared. So that's equal to 9 times 4. 9 equals 36a. A is equal to 1/4 again.